All right, last section of chapter 2.
I don't think so. If we are, I'm leaving. I think you are. I'm not. I was you did I think that's the day of. I'm not doing it. I'll give my spot to someone.
Hey, this is going to be kind of a combination of what we've been doing for the last several days. We've talked about inequalities, and especially compound inequalities. And then yesterday, we talked about absolute value equations and what an absolute value equation looked like and how to solve it. Today is going to be an absolute value with an inequality. So we're going to see less than, greater than, one of our inequality symbols thrown into the mix. And there's going to be two different kinds. Okay. The first one that we're going to do I'm just going to start with a real basic one, okay, and then we'll work into ones that are a little bit more difficult. Absolute value of x is less than 4. So yesterday when we did this, what we talked about was writing out two equations, right? Well, today it's an inequality. So it's going to look very similar to what we did yesterday. The first one that I'm going to write out, and I don't necessarily need to rewrite the absolute value in there. I'm just going to say x is less than 4. Write it exactly the same way without the absolute value. The second one, kind of like we did yesterday, we're going to make it negative. But notice what happens here, okay? Because I made this a negative, it's basically like multiplying by a negative, and so that makes me flip my sign. And so now it goes from a less than symbol to a greater than symbol. Okay? So when you do the negative inequality, you got to make sure that we flip the sign. Okay? Because of what we've talked about with inequalities, and changing the sign makes me flip the inequality. Okay, but because we talked about compound inequalities earlier in the week, and because I have two inequalities here, we have to either fill this in with an and or an or. And so I'm going to show you a little trick here that you can use, but this only works for absolute value problems. And you may have heard this before. But if my original symbol is less than or equal to, we're always going to use and. So we always say less than. It's just kind of an easy way to remember. I want to use and when it's less than. And so I'm going to put and in between these two. Okay. And when we talked about this on Tuesday, we said that it's a big deal because if it's an and or an or, changes what our graph should look like. And if it's an and, majority of the time, these two are going to meet in the middle and should connect to one another. Okay. One of the similarities that you're going to see today is they're going to go to the three parts again. We're going to write our answer in interval notation, set builder notation, and we're going to graph it. So because we're doing inequalities, anytime we do inequalities, we're going to usually express our answer those three ways. Okay, and what we've talked about is I really like to do the number line first. Make sure you put -4 further to the left. So it's going to be greater than -4, so I'm going to put a parenthesis opening to the right. X less than 4, I'm going to put a parenthesis opening to the left. And then we're going to shade everything in between those two. And that would be our graph. Okay. And I've said this several times. I like doing the graph first. If you don't want to do the graph first, you don't have to do the graph first. But I just think now it helps me to write my answer for A and B, I think, a whole lot easier. Because as I go up here to my set builder notation, I can say that x is between negative 4 and 4. Any value from negative 4 to positive 4 should work. So I think it's just a really easy way to help me write my answer rather than trying to jump right into part A. Okay, so we don't have to do it step A, step B, step C in that order. We can kind of use that to help us. And then interval notation would be very similar. We have a parenthesis on the left at negative 4, and we're going to go all the way over to positive 4 with a parenthesis. And that's our interval notation. Okay. So it's going to look very similar to what we did on Tuesday when we did the compound inequalities. Most of the problems today, you're going to have two inequalities. And so then we have to decide if it's an and or an or. Okay. I'm going to start with and problems here, and then we'll work into ors here in just a little bit. Okay, this time we have an expression on the inside of the absolute value. But once again, we see absolute value, and immediately when I see absolute value, I know we're going to do two. Okay, two equations, two inequalities, whatever it is. Yesterday it was only equations. Today we got the inequalities to it. So my first inequality is exactly the same thing without the absolute value. The second inequality, nothing happens to the x minus 4. You don't change signs or anything like that. It's just x minus 4. And then I'm going to switch to greater than or equal to negative 3. That's the big thing. We got to make sure that we get that sign flipped. If we don't get that sign flipped, then my inequalities won't match up and going to have an entirely different answer. Once again, we have a less than symbol, so this is going to be an and statement in between. The one big difference here from what we did on the first one is now I got to do a little bit of solving, right? Because x is not by itself yet, so I got to add 4 to both sides. And then we do our 3 parts. Okay, the big difference here is my symbol is a bracket on both ends. The one thing I will tell you today is you're going to have the same symbol on both ends. So it's either going to be both parentheses or both brackets. We saw some on Tuesday where we had like a parenthesis here and a bracket here. Well, for today, because we're starting with the same original symbol, they're either both going to be equal to or they're both just going to be less than or greater than. Okay, so both brackets are both parentheses. And then we're going to shade in between. Greater than 1, less than 7 would be everything in between. And then once again, we just write our answer. Hey, if you would rather write part A like this, x is less than or equal to 7 and x is greater than or equal to 1, there's nothing wrong with that. When I do the set builder notation, you could write it like that, but I like writing it like this because I think it's a little bit easier, a little bit quicker maybe. And we're just saying x is anything between 1 and 7, including 1 and 7 because of the brackets. Okay, and so I just kind of prefer writing it like that, but you could just put these right into the set builder notation with your and statement, and that would be fine too. And you might see that sometimes. But probably this is the way you're going to see it more often. Okay, and then finally for part B, we got a bracket on the left at 1. We're going to go over to 7, bracket on the end, and that would be it. Once again, trying to do these first without the number line, it's doable, but I just think it's so much easier using the number line to come up with our other 2 answers. Okay, we're going to do one more and then we're going to move in to the or statements. Okay, this one is going to be very similar to the one we just did, except we're going to end up with a little bit different numbers. And I just want to show you that it doesn't really matter the numbers that we have. You're still going to do two inequalities. All the steps are going to be very, very similar. As long as there's nothing outside of the absolute value. Yesterday we talked about if there's something outside the absolute value, we got to get rid of that first. Okay, but a majority of the ones that we're going to do today aren't going to have anything outside the absolute value to begin with. So we're good to just write our two inequalities right from the beginning. Okay, and when we do that, the first one is exactly the same thing without the absolute value. You don't have to change anything. And then the second one, okay, make sure you don't do anything with the 3x plus 1. The 3x plus 1 stays exactly the same both times. The only thing that changes is my sign, and this becomes a negative 5 instead of a positive 5. And because my original symbol is a less than symbol, then this is once again an and. So whether it's less than or equal to, we always use and every time. And from here, it's just a solving problem. We subtract 1. We divide by 3. Okay, and once again, we've seen it before, and we're going to see it again. We're going to get, bless you, we're going to get fractions sometimes. Okay, it's just part of life, unfortunately. But that doesn't mean both answers are going to be fractions, because this one ends up being a nice integer number, no fractions. So those are my two. Okay, and as we've talked about, one of the ways that you kind of know that you're doing it right is most of the time. There are exceptions to the rule, and we talked about some of those exceptions to the rule on Tuesday, but most of the time ands are going to meet. And if they don't meet, then you can kind of start thinking about why they don't meet and did I do something wrong. But most of the time they should meet, and that kind of shows you or know, that way you know you're kind of doing it the right way. All right, number line. -2, 4/3. Both of the symbols should be the same thing. So in this case, they're both going to be parentheses because there's no equal to underneath. Greater than -2 and less than 4/3. Notice that I'm not getting real specific with my number line. I mean, if you wanted to, you could. If I wanted to put like a 1 and a 2 and put 4/3 between 1 and 2, you can do that, but I'm okay if you do it like this. The biggest thing is just to make sure -2 is on the left and 4/3 is on the right. But other than that, I'm not going to ask you to get super specific on plotting those. And then we'll just say x is between -2 and 4/3. And then when we do interval notation, -2 to 4/3. Okay, they're all saying the same thing, just a little bit different way of writing our answer. Okay, on the test next week, when we have these inequality problems like this, then we'll do the same three parts. We'll do set builder notation, interval notation, and graphing it on a number line, like we're doing here. Okay, so it'll be very, very similar. So just try to get in the habit of doing those. And that's one reason why I'm giving you a work day tomorrow, is because this homework does take a little bit longer because you got those multiple parts to them, and it takes a little bit longer to do some of these. So giving you some time tomorrow to work and get caught up on all of these. Okay. The other type of compound inequality is when we have a greater than symbol. Okay, all the ones that we've done up to this point have all been less than. And so the trick we said was less than, and we're always going to use an and statement. So the trick here we're going to spell it a little bit differently than what the greater is typically spelled, but we think of it as great or. Okay, so it's just kind of an easy way to think or to write it out to help me to remember that if it's a greater than symbol, then it'll be an or statement. Okay, so less than, great or. The only time those two tricks work is when we deal with compound inequalities. So these, or absolute value inequalities, I should say. So any other time throughout the semester that those two tricks aren't going to work. So it's just specific to absolute value inequalities. Everything is pretty much the same here. We rewrite the first inequality the same way. The second one is flipped. And because my original symbol is greater than, then we're going to write or in between. So this is an or statement. What's different about or when we graph it? They should go opposite, okay? And that's what we talked about on Tuesday as well. Or and opposite. Another trick, right? O and O. Or most of the time will go opposite. Once again, it doesn't happen 100% of the time, but the majority of the time, those two should go away from one another. And that's how we kind of know that we're doing it the right way. So now when I graph this, -5, +5. This time, -5 is less than, so it's going to the left. +5 is greater than, so it's going to the right. These two never touch or intersect one another. They're going away or opposite one another. So writing the inequalities here and writing my two interval notation answers in set builder notation. For set builder notation, I would just rewrite my answers with an or in there. There's no way to really combine them together like there was with ands. Ands, we can combine them, ors, we really can't. So we're just going to rewrite it like that. Okay, for interval notation, it's a little bit different. We've talked about this before, but how far left is that graph going to go? Infinity, right? And so we know this is going to be negative infinity all the way over here to the left. So we're going to say negative infinity all the way up to -5. But then the graph takes a break for a little bit. So we put a little pause in there. And we're going to join it together. And then it's going to pick up again at 5. And it'll go 5 to infinity. And then that would be our answer. Okay, try doing this one. See if you can work this one out. Very similar to ands. I'll come around, I'll kind of help you out, see if you can do it. We'll talk about it. Then I got one more example after this, and then I'll get you your assignment. what are our two inequalities going to be? What's the first one going to be? Four x plus 1 is greater than or equal to 9. Okay, second one. 4x plus 1 is less than or equal to negative 9. Okay. So those are going to be our two inequalities. Okay, this one over here we won't go ahead and solve. We subtract 1, we divide by 4. We get x is greater than or equal to 2. Okay. Then here, 4x plus 1 less than or equal to negative 9. Don't forget to flip the sign. And then we divide by 4. Okay, and you can either write your answer as negative 5 over 2, which is a reduced fraction, negative 10 over 4 reduced down to be negative 5 over 2, or if you want to do negative 2.5. Either one of those would be fine. Okay, I still probably would go with the fraction, because if this is like a repeating decimal or something, fraction would be better. But if there is no repeating decimal, then doing the decimal would be okay. Okay, what kind of symbol are we going to want on both of these? Bracket, okay? And we know that negative 2.5 is going to open left and shade left. And 2 is going to open right and shade right. Once again, when we write this one out, we just write it as the two answers that we've solved. And it doesn't really matter which one's on the left or which one's on the right when we do that, because it's just two separate inequalities. When we do interval notation, we just want to go from left to right. So we're always going to start all the way over here to the far left, which is negative infinity, all the way up to negative 5/2 with a bracket. And we're going to start over again at 2 to positive infinity. Okay. How'd we do? You guys feel pretty good about that one? Okay. All right, one last one. On Tuesday, when we did inequalities, I showed you a couple of special scenarios that happened, right? And so that's why I tell you that like ors should usually go opposite, but sometimes there's exceptions to the rule. Okay, and should usually meet, but sometimes there's exceptions to the rule. And we talked about some of those exceptions a little bit on Tuesday. That's going to happen again here. Okay, there's going to be times where ors won't necessarily always go opposite, or ands don't always meet. Okay, and so I don't want you to think that happens every single time, but the majority of the time that's what is going to happen, or should happen. So then we have a problem that looks like this. Okay, a couple of things a little bit different about this one. Doesn't really look much different than the others, but one thing that is a little different here is we haven't done one yet today where we have some things on the outside of the absolute value. We did some like this yesterday, but that was with equations. With inequalities, that's going to change a few things, okay? So first thing we have to do is we have to get the absolute value by itself, and so we want to get rid of the 2 and the 7. Which one do I move first? The 7, yep. Just like solving an equation. We're going to subtract first. And then we're going to divide by 2. And we get to here. Okay, and immediately, and we talked about this yesterday, but once again, it was all equations yesterday. We just had an equal sign. We didn't have any inequalities. But if this was an equal sign, what would we say here? We would say no solution, right? And that could be the case here too. But I'm going to show you what's going to happen here, okay? If I write the first inequality out, x is less than or equal to negative 2. This is an and statement. X is greater than or equal to positive 2. We flip the sign, change the negative to a positive. And then we have A, B, and C. When I graph this one, they're going opposite, right? So if this was an or, it would be okay. But because it's an and, it's not okay. And so we have to decide what our answer is going to be. So what numbers are less than or equal to -2 and at the same time greater than or equal to +2? What numbers make that work? Nothing, right? Nothing works. Okay, so we just say no solution. There is nothing here that makes this work. What could happen in some cases is you could have one that's like all reals where they cross over each other and they keep going. We saw some like that on Tuesday when we did statements where they're going opposite directions, but they start on opposite sides of one another, so they actually cross over one another. So we could see ones like that as well. So those would be a couple of special scenarios that we might see from time to time. The way this is set up in your textbook is kind of like I did with the notes. I think they do mostly the ands first, and then they move into the or statements. So they're kind of organized by the part that you're doing. Okay. So I think it's about 10 questions. Probably about half and half of ands and ors. Start at 8 and then skipping every 4 problems. And I think all of them, you're doing parts A, B, and C. You're going to do interval notation, set builder notation, and graphing it. Okay, I'm going to let you guys work. We got a little bit of time here.